case study, we will be looking at cyanide poisoning, specifically the tragic incident known as the Chicago Tylenol murder case. The purpose of this presentation is to show how cyanide interferes with the body at the cellular level. Cyanide blocks the last step of electron transport chain in mitochondria, which can prevent the production of ATP. Without ATP, cells will lose their energy supply, which can lead to rapid organ failure and even death. This case is very important because it highlights the critical role of mitochondria and oxygen in cell respiration. By studying it, we can better understand how a small disruption in ETC can have such a major impact on human health.
Now, let's take a look on the case background. The 1982 Chicago Tylenol murders involved 7 people who died after taking Tylenol capsules laced with potassium cyanide. The case, which caused widespread panic, led to a massive recall of Tylenol nationwide and prompted the creation of tamper-resistant packaging for consumer products. Despite multiple investigations and the identification of a prime suspect, James Lewis, the murders remain unsolved and no one has ever been charged in the deaths. In September 1982, 7 people in the Chicago area died after ingesting Tylenol that had been poisoned with a lethal dose of potassium cyanide. The initial victim was 12-year-old Mary Kellerman, who died after taking a tainted capsule to treat a sore throat. The deaths, which included members of the same family, caused widespread fear and led to Tylenol being removed from store shelves nationwide.
The main cause of the Chicago Tylenol murders was product tampering. Someone secretly placed potassium cyanide into Tylenol capsules and returned them to store shelves. When people took the medicine, they unknowingly swallowed the cyanide.
The first one is a product vulnerability. At that time, a Tylenol capsule could be easily opened and reserved, making them becoming a target for tampering. The second one is public fear. Cyanide is highly lethal, and the sudden unexplained deaths caused widespread panic. The third one is media coverage. This case received massive national attention, amplifying consumer anxiety and distrust. For the last one is unknown culprit. The fact that the person behind the tampering will never be caught deepened the people's fear.
Now, let's see how ETC works.
An ADH is reduced to complex 1 with 2 protons and 2 electrons. 2 protons are shuttled from matrix to intermembrane space. Ubiquinone carries protons and electrons to complex 3, where protons are moved to the intermembrane space.
FADH reduces complex 2 with 2 protons and 2 electrons. Ubiquinone carries this proton and electron to complex 3, where these protons are also moved to intermembrane space. Then, these 4 electrons are transported one by one to complex 4 by cytochrome C.
Cyanide binds with the cytochrome C oxidase. This enzyme is the final gatekeeper in the electron transport chain function to transfer electron to oxygen. But cyanide binds to the ion center of this enzyme, effectively blocking the path of oxygen. Even though there's plenty of oxygen in the bloodstream, but without oxygen, cells struggle to produce adequate energy in the form of ATP through oxidative phosphorylation.
For information, we can treat the cyanide poisoning by using the triad antidote, which is sodium nitrate, sodium thiosulfate, and hydroxycobalamin. Sodium nitrate was injected in our bloodstream to oxidize the hemoglobin Fe2+ to methemoglobin Fe3+. As a result, cyanide binds to the methemoglobin, forming cyanomethemoglobin, which is far less toxic. The cyanomethemoglobin binds with the cyanide at the cytochrome C and less freely in mitochondria. And then the cytochrome C will do its function to carry the electron to the complex 4. After all the antidote treatment, the electron transport chain is reactivated, restoring the proton gradient and enabling ATP synthase to resume the normal ATP production. Sodium thiosulfate also injected in our bloodstream. Sodium thiosulfate works with liver rhodanase to convert the cyanomethemoglobin into thiocyanate. The thiocyanate was excreted harmlessly in urine. Next, hydroxycobalamin. Hydroxycobalamin combines with cyanate to form cyanocobalamin. Cyanocobalamin, which is the non-toxic molecule. Cyanocobalamin is then excreted in the urine. In conclusion, the Tylenol murder case in 1982 demonstrate the deadly potential of cyanide poisoning to our body, where even a little amount of it can damage our cellular respiration and cause a sudden death. More importantly, it emphasized the need for fast recognition, availability of antidotes, and hospitality readiness in managing the cyanide poisoning. Ultimately, the tragedy became a turning point in improving the toxicology practices and awareness of the dangers of cyanide in the community.